What if you traveled at light speed? Imagine for a moment that you could travel at the speed of light. What would happen to you? What would happen to time, to space, to reality itself? It's a question that has captivated scientists and science fiction writers alike. Let's embark on a journey to explore the mind-bending consequences of reaching the ultimate speed limit. Light speed is truly mind-boggling. We're talking about 299,792 kilometers per second or 186,000 miles per second. To put that in perspective, a beam of light can circle the entire Earth nearly 7.5 times in just 1 second. So what would it actually feel like to move that fast? Surprisingly, if you were inside a spaceship that instantly accelerated to light speed, you wouldn't feel anything particularly special. Assuming, of course, that the acceleration didn't squash you first. It would be similar to how you don't feel the Earth spinning beneath your feet. You'd be floating in your cabin, perfectly normal. But while everything might seem normal inside your ship outside, things would be anything but. One of the most bizarre effects of traveling at light speed is time dilation. According to Einstein's theory of relativity, the faster you move, the slower time passes for you relative to a stationary observer. As you approach light speed, time slows down dramatically, almost to a standstill from your perspective. This opens up some incredible possibilities for interstellar travel. You could cross vast distances, even travel to other galaxies, in what feels like just a few hours or days. But when you return to Earth, years, decades, or even centuries could have passed. In a very real sense, you would have become a time traveler, journeying into the future. Einstein's theory suggests that light speed is essentially a one-way ticket to tomorrow. Another strange consequence of light speed travel is length contraction. Space itself would appear to shrink in the direction of your travel. The faster you go, the more compressed the universe becomes. Distances that would normally take thousands of years to cross could be traversed in what seems like a very short ride. For example, Alpha Centauri, the closest star system to our own, is about 4.3 light-years away. At light speed, that distance could be covered in a matter of minutes from your perspective. The entire universe would appear smaller, more compact, and within reach. Now, here's the catch. Reaching light speed requires an infinite amount of energy. As you accelerate, your mass increases, making it harder and harder to go faster. To actually reach light speed, you would need an infinite amount of energy to overcome your infinite mass. This is a fundamental physical impossibility. Nothing with mass can truly reach the speed of light. You could get incredibly close, but you can never quite get there. Even if we could somehow overcome the energy barrier, reaching light speed would create some serious paradoxes. Consider a photon, a particle of light that is always traveling at light speed. From the photon's perspective, no time passes at all. It is created and absorbed instantaneously. If you were traveling at light speed, time would essentially stop for you. Your clocks wouldn't tick, you wouldn't age, and you wouldn't experience any passage of time. There would be no waiting, no anticipation, just an instantaneous jump from one point to another. While reaching light speed remains firmly in the realm of theoretical physics, we are making progress in achieving significant fractions of it. Current spacecraft are nowhere near light speed. The Parker Solar Probe, one of the fastest spacecraft ever built, reaches speeds of about 0.06% of the speed of light, but future technologies hold promise. Warp drives, ion propulsion, and laser-pushed sails are all potential avenues for achieving much higher speeds. Perhaps one day we will be able to explore nearby stars within a human lifetime. So, what have we learned about the consequences of traveling at light speed? We'd be leaving behind time as we know it. Space would shrink, making vast distances traversable. Energy would be our ultimate enemy, preventing us from reaching the ultimate speed limit. And reality itself would be altered in ways that are difficult to comprehend. If you enjoyed this exploration of the impossible, be sure to subscribe and like Science Labs Express for more mind-bending science.